On to Chapter 9, Fixed, Wet, and Dry Chemical Extinguishing Systems. Objectives. Describe the characteristics of fixed, wet, and dry chemical extinguishing systems. Discuss the hazards fixed, wet, and dry chemical extinguishing systems are most likely to protect. Describe how fixed, wet, and dry chemical agents control and extinguish fire. Describe a pre-engineered system. List the major components that make up fixed, wet, and dry chemical extinguishing systems. Describe the types of fixed, wet, and dry chemical extinguishing systems. Discuss the various acceptance and periodic inspection, testing, and maintenance requirements for fixed, wet, and dry chemical extinguishing systems. Fixed, wet, and dry chemical extinguishing systems are an alternative to water in cases where water would have little effect, no effect, or cause harm. Fixed, dry, wet extinguishing systems extinguish flammable and combustible liquid fires. Similarities between systems, such as similar components, similar design and operational characteristic, pre-engineered in many instances, use of gas to expel the agent, operation by manual and automatic means, and finite availability of extinguishing agent. Design professionals must take these factors into consideration: environment, equipment, type of system, and the amount of agent needed to control a fire. Fixed, wet chemical extinguishing systems. These systems protect commercial kitchen appliances that generate greasy vapors from food. They also protect the associated ductwork, exhaust hoods, filters, and plenum chambers above the appliance. Wet chemical extinguishing agents are proprietary water-based solutions mixed with potassium acetate, potassium carbonate, potassium citrate, and sometimes a mixture of these and other additives. The solution is the medium for the agent to flow onto the hazard. The agent reacts with cooking oils and forms a soapy foam blanket that comes between the oxygen and the fuel. This reaction is called saponification. It essentially smothers and kills the fuel, preventing reignition. Manufacturers develop mixtures for their appliances and then apply for listing or approval from a third-party testing agency. These agents are generally harmless to humans. They may corrode or stain equipment if not cleaned properly. These agents are the most effective agents against your Class K fires. Fixed dry chemical extinguishing systems. These systems have been used since the 1950s to protect equipment and processes against flammable and combustible liquid fires. They protect paint spray booths, dip tanks, self-service fuel pump stations, and equipment that use hydraulic oils. They also may be effective for energizing electrical equipment and ordinary combustible fires that are not deep-seated. They are no longer used for commercial cooking appliances because they do not meet the current test and performance standards. Dry chemical extinguishing agents are small solid particles that use a pressurized gas, such as nitrogen, carbon dioxide, or air, as the transport medium. They may be applied by a fire extinguisher or a hose line. The agents knock down flames and smother the protected surface area of a fire. The oxygen essentially is cut off from the fuel to prevent reignition and flame spread. These particles suspended in the gas to facilitate the distribution of the agent. After the system activates, the particular gas mixture flows out of the container through the nozzle. The nozzle type and placement depends on the hazard and its protection requirements. These agents are effective on surface fires where other agents would run off before they could adhere. The categories of these agents. You have three. You have sodium bicarbonate base, which works well on Class B and C fires. One of the oldest and most widely used dry chemical agents on cooking-related grease fires. It can be white or blue in color. The next one is a potassium-based. It works well on Class B and C fires as well. It is similar to sodium bicarbonate, but much more effective because lesser amounts provide more fire extinguishing capability. It is purple in color. The third agent is ammonium phosphate, which is a multi-purpose dry chemical that works well on Class A, B, and C fires, and it is yellow in color. These agents are not considered dangerous or toxic. They do not react with flammable gas and liquids, and they do not conduct electricity. Once discharged, they can create a cloud that limits visibility and cause respiratory issues. Some of these agents leave corrosive residue that can damage the equipment and components if not properly cleaned. Automatic activation. A fire has to build to such a level that it sets off the automatic sensing device near or within the protected area. You also have manual activation, which a person must physically contact with a releasing device such as a manual station to start the extinguishing process. Once control panel receives a signal from either an electronic or mechanical release, starts simultaneously. The agent flows. It also controls the associated utilities and an alarm will sound. Depending on the system design, the sequence could evolve in different ways. If a container holds the agent and expels gas, then a valve on it opens and the agent flows through the piping to the nozzle discharged to the hazard. If the expelling gas is in a separate container, a valve opens to let it flow into the container that holds the agent. If there is a gas cartridge, a puncture in its seal will release the gas into the container that holds the agent. If the agent discharges, audible and/or visible alarms will activate. If the building has a fire alarm system, the extinguishing system will tie into it. Code requirements call for on or off-site monitoring. The flow of fuel source is associated with electrical supplies, processes, and operations must simultaneously terminate. After the fire event, the extinguishing system and all its components require repair, replacement, or recharging before they can return to normal service. The basis of any system design is the amount of agent needed to protect the hazard. Sometimes pre-engineered systems can be adapted to different situations. Other hazards require full engineering. Specific conditions exceed the capacity of pre-engineered systems. Once the amount of an agent is determined, the design system is complete, which includes the size and number of containers, piping, nozzle, and other components. Standards do not have specific design parameters. Each manufacturing agent and components are different. The standard includes the following: general design consideration, information about which hazard the agents are suitable to protect or not protect, requirements for system activation and supervision, and the requirements for acceptance testing, inspection, and maintenance. Here are the specific standards to deal with the system: NFPA 17A, NFPA 17. Both NFPA 17A and 17 give information and guidance on purchasing, design, installation, testing, inspecting, approval, listing, operating, and maintaining the wet or dry system. NFPA 96, the standard for ventilating control and fire protective commercial cooking operation, covers your minimum requirements again for design, installation, operation, inspection, testing, and maintenance of public and private cooking operations. It establishes automatic fire extinguishing equipment protection requirements for exhaust hoods, duct systems, exhaust plenums, and grease removal devices. The Internal Mechanic Code covers the ICC-based requirements. Underwriter's Laboratory. UL 300 standard for fire testing a fire extinguisher system for protection of commercial cooking equipment. UL 1254 standard for pre-engineered dry chemical extinguisher system units. Both UL 300 and UL 1254 have specific requirements for pre-engineering wet and dry chemical extinguisher systems, as referenced in NFPA 17 and 17A. 17A requires that pre-engineered dry chemical systems meet UL 1254 or an equivalent standard. UL 1254 covers the operation and construction of fixed dry chemical systems for such things as restaurant cooking areas, industrial total flooding protection, automobile service stations, open-faced and vehicle paint spray protection, Class B fire local application protection, and off-road vehicle protection. Both UL 1254 and NFPA 96 reference UL 300 as a standard to follow when establishing fire extinguisher protection for cooking operations. Agent storage containers and gas cartridges. Storage containers must be made of metal that will not react with the agent. The container requirements must be able to handle high pressures. They must be sized accommodated in the amount of agent needed. The capacity ranges from 1.5 to 6 gallons. Pre-engineered systems are designed to deliver a certain amount of agents, so the entire container capacity must be available for it. Many manufacturers do not combine the wet chemical agent and expelling gas. Gas is stored in a separate cartridge that pushes the product out of the tank. On pressure tanks, it activates a valve to move the agent into the piping. Sometimes the manufacturer will ship the agent separately in plastic containers. When installed, the container and cartridge need to be located so that the manufacturer's wet agent is kept in the appropriate temperature range and to avoid damage or exposure to the hazard. Container sizes. Dry chemical containers can be bigger than wet chemical containers, depending on the hazard. Containers can hold hundreds or thousands of pounds of a dry chemical agent. Larger, energized hazards may require separate containers for the agent and gas. The containers must also be as close as possible and practical to the hazard. Smaller pre-engineered installations that are used to protect against commercial kitchen hazards require a small container. Regardless of container size, installation conditions should not promote heat or humidity or subject containers or other agents to any other damage. All containers must meet the U.S. Department of Transportation guideline for storage and shipping. Piping and fitting. Piping and fittings distribute the wet or dry agent to the nozzle. They must be made of non-combustible materials and able to handle anticipated pressures. Usually they are made with metal approved for use with a specific agent and system. Wet systems usually use Schedule 40 black iron, chrome plated, or stainless steel pipe and fittings. Hot dip galvanized iron pipe is not usually used because it can flake and clog the nozzle. Dry systems use galvanized steel, stainless steel, copper, brass, other specialized material for corrosive environments. Black steel is used for non-corrosive environments. Certain types of steel pipe, cast iron, aluminum, and non-metallic materials are not approved. The installed fitting includes elbows, T's, and couplings. The arrangements and size of the chosen pipe depends on the hazard and the agent. These are standards in wet chemical systems because they are pre-engineered, tested, and approved for the size and type of the hazard. These are mainly commercial cooking appliances. The contractor must follow the manufacturer's published installation guidelines. Many new dry chemical systems require engineering to determine pressure, arrangement, pipe size, fitting selection, and fitting location. Good engineering is critical to fluidize the proper mixture of dry chemical and the agent. Nozzles are the means of distributing the agent on the hazard. There are different types of wet and dry chemical systems. Each type is designed for an intended application and must be listed for that application. Nozzles must have a permanent marking to identify the type. The selection and arrangements of the design are based on the desired application, the hazard, and the amount of agent required. There are other specific requirements for nozzles. NFPA 17 and 17A require nozzles to be non-combustible and not to deform when exposed to fire. They must be made of brass or stainless steel, or a corrosion-resistant material must protect them. There must be a blow-off cap or other approved protection devices or material to cover the nozzle's orifice. This prevents clogging of the orifice. When installed on wet chemical systems, they must have a built-in strainer or inline strainer. Activation devices. Extinguishing systems operate by manual or automatic activation. Each is independent to ensure the failure of one does not inhibit the other. Automatic activation occurs through a mechanical or electric sensing device that is located in the hazard area. An example of a mechanical device would be a fusible link. An example of an electric sensing device is a heat detector. NFPA 17, 17A, and the IBC require that wet and dry chemical systems employ manual activation via some kind of pull actuator. Typical manual station type devices near the protected area in the path of egress. They should be no less than 42 inches and no more than 48 inches above the floor. They must be clearly identified and the protected hazard. Provide operating instructions and require no more than 40 pounds of force and a maximum of 14 inches to activate the fire suppression system. The IBC requires that manual activation devices for commercial cooking equipment be at least 10 feet but no more than 20 feet from the kitchen's exhaust system. All activation systems must automatically operate any associated safety equipment and shut down and heating fuel or power supply to the hazard. System alarm and indicators. When a wet or dry chemical system is activated, it must initiate an alarm signal. If the building has a fire alarm system, the extinguishing system is tied into it. It must activate signals indicating alarm, supervisory, or trouble. If the building does not have a fire alarm system, a local audible or visual indicator can immediately alert to a fire. This is especially important when it's a dry chemical system because the chemical produces a potentially dangerous cloud of powder that can affect breathing and visibility. Supervisory alarms are required with electrical or pneumatically controlled systems. Mechanical or electrical audible or visual indicators must be on both wet and dry systems so an individual knows the status of the system or the need to investigate. There are two types of fixed extinguishing systems. Local application systems are needed when a hazard is exposed and thus unable to contain the agent. Total flooding systems are the best protection. Enclosed hazards are those in confined areas. The local application system. This system protects a specific area, piece of equipment, process, or operation. It can be used wet or dry extinguishing agents based on the hazard. It discharges directly into the hazard to smother, cool, and extinguish the fire. To be effective, the system must protect the entire hazard, and the hazard must be isolated from other hazards. An indoor example is a cooking appliance. An outdoor example is a vehicle fuel island, as seen at a gas station. Total flooding systems. These systems protect enclosed hazards and areas within a structure. Examples where they would be used are protection of paint spray booths and flammable and combustible liquid storage areas. A dry chemical agent fills the entire area to smother, cool, and disrupt the fire chain reaction. The amount of agent and the number of nozzles needed depends on the area's total volume and the extinguishing system and manufacturer specifications and approvals. For some agents, especially gas-based, suppression requires sealing or minimally opening the protected area. Protection should include automatic shut-off of openings and stop forced air ventilation systems before or during discharge. This ensures the concentration of the agent does not decrease and result in adequate suppression. If openings cannot be closed, another agent must be added to the design. Other wet and dry chemical application methods. There are a number of different application methods, including hand hose lines. Hand hose lines can stand alone or supplement extinguishers or fixed dry chemical systems. They can be installed with a fixed dry chemical system that cannot provide adequate protection if approved by the government authority. It should have a separate dry chemical supply that can last for at least 30 seconds. If both systems share the same supply, only one can operate at a time, and there must be a 30-second supply for both. Hand hose lines must be accessible and able to reach the hazard. They should not be placed where they will be exposed to the hazard, and the nozzle must have a shutoff device. After installation, extinguishing systems must undergo acceptance, inspections, and tests to ensure performance. The requirements are laid out in NFPA 17 and 17A. The process is simple for both kinds of systems, but many interconnected systems require appropriate operation for final acceptance. As system agent, periodic inspection, testing, and maintenance are required to maintain system integrity. Some inspections can be done by the facility maintenance staff, but others require trained personnel. Visual inspections. Visual inspections confirm that equipment is located and installed in accordance with the approved plans and their supporting documents. Inspections include verification of correct nozzle type and proper operation and location relative to the hazard. Other components of the visual inspection is ensuring correct piping material, size and length, correct agent, type, and amount. Inspections also determine if auxiliary equipment is in the correct location, is the correct type, and is free from damage or any condition that will inhibit operation. Alarm bells, manual releases, and fusible links must also be checked. Discharge test. This test ensures that the appropriate amount of agent is discharged from the system nozzle and all associated equipment functions properly. Balloons, containers, and bags are attached to the nozzles to capture the agent when it is discharged. The agent is then weighed to ensure the proper amount reaches each nozzle. Capturing and weighing of the product is more important for dry chemical extinguishing systems than wet. For wet systems, some manufacturers recommend discharging a gas propellant, water, or a special testing fluid instead. This avoids corrosion, although this can also be accomplished by flushing the system with water and blowing out air after discharging a wet chemical agent. If water is used, some manufacturers recommend using their flushing fluid. Discharging the agent, water, or a pressurized gas also confirms that the piping is not clogged. Acceptance test. This test confirms proper operation by manual or automatic release. Activating the manual release, automatic release, or fusible link all cause a number of different safety processes to initiate. All processes are intended to minimize the possibility of fire spread. Each process is independent of the others to ensure backup. Process includes fuel shutoff to equipment, electrical supply shutoff to equipment, supply air shutdown, alarm evacuation, and exhaust fan shutdown and damper closing. If there is an exhaust fan associated with the protected hazard, neither NFPA 17 nor 17A requires the fan shutdown or dampers to close. Some manufacturers' listings and government authorities may require fans to remain operational to remove the smoke and gas. Once all discharge and acceptance testing is complete, they are recorded by placing a tag with a month and year of testing on the equipment as a reminder for the next test and inspection series. Periodic inspections, testing, and maintenance. Inspection. Visual inspection should occur on a monthly basis. Depending on the hazard, frequency of inspection could be greater. Visual inspection verifies that there is no obstruction to equipment or manual releases, no coating or deposit on nozzles or equipment. The protective blow-off caps or orifice covers are in place and not damaged. Nozzles are in proper location. Auxiliary systems are in place and ready. There is no visible corrosion. Pressure gauge is in the normal range. The hazard process and equipment remains as originally designed, approved, and installed. If there is an indication of replacement, modification, or relocation during the visual inspection, the system must be redesigned to meet the new conditions. During semi-annual inspections, the same visual inspection should be performed as during monthly inspections, with some additions. Dry chemical systems that use cartridges must also be checked for proper pressure and weight. Inspection of dry chemicals also ensure that the agent remains in the proper physical state, i.e. powder, to flow freely. Lumped or caked dry chemical agent should be replaced immediately. Every 6 years, any dry chemical agent in a stored pressure container must be disassembled, the container inspected, and the dry chemical agent replaced. Testing. Periodic testing ensures the system is operating as designed and identifies problems. Results of monthly and semi-annual inspections determine the necessary level of testing. Most testing is, however, semi-annually. When inspection reveals a problem, necessary maintenance and testing should take place immediately. Corrosion, leaks, damage, and equipment repairs require further investigation and possibly more extensive testing and maintenance. At a minimum, manual and automatic system activation determines if alarm activates and if fuel and electrical shutoffs shut down. To activate the system, NFPA 17 and 17A do not require the agent to be discharged. Expelled gas, the level of performance can determine. Some insurances or government authorities require full discharge. Once the product is captured in bags or balloons, it is weighed again to ensure the appropriate amount is delivered to the nozzle. Internal piping should be clear and dry to avoid blockage and corrosion. Maintenance. Routine maintenance usually follows manufacturer guidelines. Some conditions may require maintenance to occur before it's scheduled. Aside from the results of monthly and semi-annual testing, certain activities take place at prescribed intervals, such as fusible metal alloy type fixture temperature sensing elements should be replaced annually. If they are not fusible metal alloy type, they do not have to be replaced and can remain in service as long as they are inspected, cleaned, and replaced as necessary every 12 months. Some system piping and nozzles should be removed and internally examined for clogging. Other maintenance and component replacements take place when there are signs of corrosion, leakage, or system damage. Some manufacturers recommend a full discharge test every 6 years. The container and any other components exposed to high pressure require hydraulic testing every 12 years to ensure integrity is maintained. When performing a visual inspection, component test, or required maintenance, the equipment should be tagged so that the responsible party knows when inspection and testing is occurring. Records should also be kept for review by responsible parties or authorities. Summary. Wet and dry chemical extinguishing systems provide an alternative protecting agent when the use of water may not be appropriate. Wet chemical agents are a mix of water and other chemicals that form a proprietary liquid that once discharged creates a soapy foam barrier between the fuel and oxygen. This prevents reignition and cools the fuel. Dry chemical agents knock down the flame and coat the hazard. The chemical covers and smothers the hazards and prevents oxygen from reaching the fuel. This stops reignition and flame spread to adjacent areas. Many wet and dry extinguishing systems are pre-engineered and can be adapted to handle different hazards. In addition, these systems use similar components and operate in a similar manner. Wet chemical systems typically protect commercial kitchen cooking appliances, and dry chemical systems typically protect flammable and combustible liquid hazards. NFPA 17, 17A, NFPA 96, and UL 300, as well as UL 1254 are the standards that apply to the design, installation, inspection, testing, and maintenance of wet and dry chemical extinguishing systems. There are two general types of wet and dry chemical systems: the local application and total flooding system types. Local application systems discharge the agent directly onto an exposed hazard to prevent fire spread beyond that hazard. Total flooding systems protect enclosed areas by discharging the agent and filling the entire enclosed area with the agent. All wet and dry chemical systems require both automatic and manual activation capabilities. Upon activation, an alarm must sound, and associated mechanical, electrical, or plumbing systems must shut down. Wet and dry chemical extinguishing system acceptance and periodic inspections, testing, and maintenance are critical to ensure the system will operate as designed to protect the hazard. Okay, gang, if you have any question, you can email me at aroberts@athenstech.edu, or you can give me a call at the office. So until next time, stay safe and have a wonderful day.